Alright, so today what we're going to be doing is taking a look at section 1.5, which is really dealing with concepts from geometry. We'll look at just a few different things and how they all work together. And so let's go ahead and just jump into the notes here real quick. And there's a lot of definitions on this document. I really encourage you just to have this handy and right in front of you. You can just refer to it anytime you need it. So really just, again, I'm not going to go through every single piece of these definitions, but I just want to highlight a few of the big ones, okay? First and foremost, let's take a look at an angle. So an angle is formed when two rays start from the same point and one ray is twisted from that point. We call that point a vertex. So we use the symbol this is an angle symbol for angles. Degrees are, it's a measure of angles. So a circle has 360 degrees. You may have heard the term, I'm pulling a 180. So you're going backwards the opposite direction. It's a straight line if the vertex is right in the middle. The way that we write measures of angles is the measure of that symbol again, that angle symbol, and we just name whatever the angle is that we're calling it. So in this case, it's just called angle C, is 40 degrees. So again, this is just saying that the measure of angle C is 40 degrees. These are some pretty big ones right here, okay? So a right angle is a 90-degree angle for a quarter of a revolution. So perpendicular lines are intersecting lines that form right angles. So how does that work together? Well, if you take a right angle and you actually split it into two separate components that are added together, that actually they would be complementary angles. So the two angles added together form a 90-degree angle, and the same kind of applies to a supplementary angle, except the difference with a supplementary angle is that it forms a 180-degree angle. So if you take two right angles and add them together, you get a supplementary angle, that they are both supplementary with one another. Alright, so straight angle is 180 degrees. Like I said before, it's a straight line. The two other sections that we'll see here in these notes, there's perimeter definitions, so measuring the distance around certain shapes, and then there's area definitions, which is the way I like thinking about it is this is like two dimensions. So moving along one side and then up another, the area measuring area inside of different shapes. And perimeter is measuring the distance or length around certain shapes as well. So this is around certain shapes. The one below it, area, is within the amount of space inside of a shape. All right, so there's a few different definitions here for perimeter. For triangles, you add up all of the sides. For the really, these are, again, just specific definitions of triangles. Parallelogram, it's just a four-sided figure with opposite sides parallel. A rectangle is a type of parallelogram, and a square is a type of rectangle. So again, this is just some definitions. Rectangle, the perimeter is just 2 times the length plus 2 times the width, or the length plus the length plus the width plus the width. A square, it's just all sides added all up to each other within one another, so that's 4 times the side. Circles are unique because they have a circumference, and I don't know if you know this, but it's really difficult to measure exactly the circumference of a circle or the perimeter of a circle. And the reason why is because pi, which I mentioned at the very first section that we talked about, section 1.3, it's actually an irrational number. which means it's a decimal that goes on forever and has no pattern or repeating digits. So it's kind of an interesting side note, but pi is a very useful application or a very useful number for a number of different applications. In computer science, it's used all the time to measure the effectiveness and the speed of certain processors. So if you're into computing, you're really curious to see like how do processors work in computers. The computer's pretty much doing all the work. They actually measure the accuracy and the speed of processors just by how they can compute pi. So kind of an interesting little side note. Another interesting side note regarding circumference, if you wanted to measure the entire diameter, or I should say the entire, if you wanted to get pi to within a certain threshold to measure the entire circumference of the universe, okay? Like the biggest thing that we know of, the entire universe, right? If you wanted to measure pi, or the universe, down to an accuracy or precision of like 1 electron, like something that's insanely small, right? To the accuracy of 1 electron, you would only need 43 digits of pi. Like that is kind of insane when you think about it. So pi is a super applicable number. We use it all the time. And so in this class, what we're going to do is we're just going to use 3.14 to represent pi. We don't need anything further. But pretty helpful. Again, I'm just going to refer back to a lot of these definitions when we're working on these problems, just so you can see how they all function and work together. For the area, we've got the measure. So again, like I said, the measure of the amount of surface in a region. So it's the amount of area within an object, the amount of space within an object. Here are the specific definitions of those formulas. The rectangles, you multiply the length times the width. The square, you square the sides to get the area. For a parallelogram, you take the base times the height, and we'll probably look at a specific example of this. For a circle, pi times the radius squared. The radius is just the center point, a line segment from the center point to the edge. And a triangle is 1/2 times the base times the height. So let's go ahead and look at some problems. You're probably getting bored of all these definitions sitting here in front of you. So let me pull my board up here. And let's go ahead and take a look at complementary angles. Again, it might be helpful just to have that pulled up in front of you just to refer back to it. I'd probably spend some time just memorizing that stuff if you haven't seen it before, because a lot of this stuff is information and just terminology that we're going to use not only in the rest of this course, but in the future courses too. If you have to take intermediate algebra and college algebra, you will certainly have to know what a lot of these things are. So question 13, this one says find the complement of a 62-degree angle. The complement of a 62-degree angle. Okay, so the key word here is going to be complement. All right, let me switch back to the notes and we'll take a look at what that was. So remember, complementary angles are when two angles are added together. Right here, two angles added together to form a 90-degree angle. Okay, let's go back. So two angles added together form a 90-degree angle. What that means is that if we're trying to find the complement of a 62-degree angle, we're looking for the other side that will add up to 90 degrees. So here I am looking for, say, angle, I'll call it angle A, plus 62 degrees is equal to 90 degrees. Okay? And now when you have degree measures, you can add and subtract them just like you normally would. So what here would you add to get 90 degrees from 62? So to do this, what you can do is you can subtract 62 from both sides. And what you'll find is that angle A is going to equal 90 minus 62. So 90 minus 62 is going to be 28 degrees. Okay? So again, you can think of this as just like what added to 62 is going to equal 90. So that right there is how you would do a problem like this. The definition is kind of tied into the words that we're looking at, or the problem itself is kind of tied into the words in the question. All right, question 15. It's something similar. It's asking us to find the supplement of a 48-degree angle. So find the supplement of a 48-degree angle. Little note there, it's angle, not angel. Angel is with an EL at the end, not an LE. I see that all the time. It's kind of insane. All right, so let's find the supplement. So what does supplement mean? Let's switch back. Supplementary angles are when two angles are added together to form 180 degrees. Okay, so what that means is similar to what we had last time. I'll have angle A plus 48 degrees is equal to, instead of a 90 degrees this time, we're going to do 180 because that's what the word supplement means. So to go ahead and find out what that is, what number added to 48 would equal 180? Well, to do that, you can subtract 48 from both sides. Okay. And I'm subtracting that right there just because I want this to go away and I want it to be 0. So I'm left with angle A on the left-hand side, and on the right-hand side, 180 minus 48, which is 132, I believe. Yeah. That's a mental math thing right there. So that right there is our final answer. The supplement of a 48-degree angle is going to be 132. All right. So your eraser's not that great, huh? Okay, 27. Let's take a look at this one. We're given a diagram. Yay. 27. So what they give us is this. Let me show you real quick. And this right here. This is O. This is point A right here. This is point B right here. And point C right here. Okay? And they say that, what am I looking for? Oh, okay, that guy. So the whole thing, that guy right there, which represents this whole angle, right? This is 138 degrees. And this one they say is 59 degrees. So that little small guy. So they want us to find angle AOC. So in other words, when you see something that looks like that, you start at the point, the very first letter, you trace yourself down to the second letter, and then go, actually I got this backwards, sorry, this is C right here, and this is B. You follow it down, and then you trace it up to the third letter where it ends. So A, O, C. Okay? So 138 degrees is the whole arc right there, and then this is what they give us right there. So I know the whole thing, and I know that small one. So what you can do is, I'm actually trying to find this little, that angle measure right there, the dotted line, okay? So in order to do that, you take the big one right there, the 138, and you would subtract this. So 138 degrees minus 59 degrees is equal to, what do we see here? 79 degrees. So there we go. It's our final answer. All right, let's keep going. I'm going to pull something up here real quick on my screen. You probably won't be able to see it. I just want to take a look and make sure I'm doing this. Okay, let's find the perimeter of a triangle. So let me write this out. Find the perimeter of a triangle. I'm going to draw a little triangle right there because I don't want to write the whole thing out, whose sides are 2.51 centimeters, 4.08 centimeters, and 3.12 centimeters. Okay. So remember, the perimeter is equal to, and for triangles, let's go back to our notes. For triangles, we're looking at the perimeter definitions, and it looks like the perimeter is going to be the first side, second side, and third side all added up. Okay? So this is side 1. My camera just shut off, and I don't know why. Might have to reset this thing. Give me just a second. Yep. Hang on. Sorry about that. I don't know why my program just crashed. All right, so side 1 plus side 2 plus side 3 and then what we have, so you can see that side 1, side 2, side 3. So what we have is we know the sides are all that. So the perimeter is just going to equal 2.51 plus 4.08 plus 3.12. And that is going to equal, you can use a device for this, like a calculator if you want to. I'm going to try to do this in my head. I'm going to do the decimals first. 0.08 plus 12 is going to be 0.2. 0.2 plus that is going to be a 0.71. And then I've got 2 plus 4 plus 3. So 4 plus 3 is 7, 8, 9. 9.71 centimeters right there. Okay. It's helpful just to get in the habit of trying to do this mental math, but you can always use a device just to. I like thinking of like your brain is your number 1 tool and your calculator is your number 2 tool. You should never use your calculator as the number 1 tool and your brain as the number 2 tool. It should never be that way. You should always use your brain first and then your calculator as a backup. So that's how you do that. Let's go ahead and take a look at a circumference problem, just so you can see what it looks like. So I'm going to look at 41. 41 is asking us to find the circumference of a circle, so whose diameter is 1.2 meters, and they say use 3.14 for pi. Okay. Now I want to go back and make a distinguishment here real quick in the notes, because this is an important distinction. Notice with a circle, there's actually two specific definitions that we need to know. One is diameter and one is radius. Diameter involves the entire length that goes right through the middle. Okay, so that's from one edge to another edge, but it goes right through the center point. The radius is only from the center to the edge. Okay, now in the definition of circumference, we have one or the other. So you have to be aware in the problem when you're looking at it. Sometimes they might give you diameter, sometimes they might give you radius. You have to make sure that you're using the right definition based upon whether they give you the radius or they give you the diameter. Okay? If they don't give you the radius but only give you the diameter, you can use this equation, or you can convert the diameter into the radius by dividing it by 2. I'm not going to go into doing that because we have the definition. If we have to use that little strategy when we go and solve for area, then I will do that. But for now, let's just use the definition that we have. So the perimeter is equal to pi times d, which is diameter. So this is equal to pi times 1.2, and in this case, this is going to be 3.14 times 1.2. And that is going to equal 3.768 meters. Listen, I know my limits, and I do not want to do that right now in my head by arithmetic. So I've actually already done it, and so yeah, there you will find that this is the answer. One thing to keep in mind is make sure that you always include the units at the end. If they start with units, so diameter is this, you need to make sure you include units as well in your answer. So don't forget that. All right, let's go ahead and keep on trucking. All right, I want to do a couple more problems. Let's just go ahead and try one of these. There's a couple applications problems. Yeah, that one. I don't like that one. Let's do this. How about... I think this is a pretty similar question to what you'll see on the homework assignment, so let's just do it. It says a drip irrigation... I'm going to read it. I'm not going to write the whole thing out, so pay attention. A drip irrigation system is installed around a circular flower garden that is 4 feet in diameter. Okay, so I'm going to write down the important pieces here. 4 feet. I have not done this, by the way. I have not done this problem, so bear that in mind. I'm going to pull out my handy calculator to do the challenging stuff. 4 feet in diameter, so there's diameter. If the irrigation system costs, so, what do we do with this? There's a cost involved. Oh boy. $2.46 per square feet, or sorry, per foot. Find the cost to place the irrigation system around the flower garden. Use 3.14 for pi. So pi is equal to 3.14. Okay. Now here is the thing. This is actually a two-step problem. The very first thing that we need to do is we need to find the circumference. So the perimeter is equal to, we just did it, pi times d. So this is equal to 3.14. So we need to find, if you're looking at like a circular shape, we need to find the entire perimeter around this thing. This is like your flower garden, I think, is what the question is here. By the way, speaking of applications, a drip irrigation system is installed around a circular flower garden. My father's a business owner. He actually does landscaping and drip irrigation systems. So this is something exactly that he would probably run across if he's trying to figure out the cost of product that he would need for installing circular systems. All right, so 3.14 times 4 feet is, let's go ahead and punch it in. 3.14 times 4, and we get 12.56. Okay, so this is 12.56 feet. Remember to label your stuff. All right, we're not done yet. So if the cost is going to be 2.46 per foot, this is perimeter, not area. We'll get into that in a minute. If the cost is 2.46 per foot, what we do is now we just do another multiplication. So the total cost is going to be $2.46 times 12.56 feet. Okay, that's a 2. It's $2.46, and now we'll just go ahead and punch that in again. So 2.46 times 12.56 is equal to 30.8976. Okay. Question. Well, it is going to be dollars. Question. Can you have hundred? So this is tenths, hundredths, thousandths, 10,000ths. Can you have that in terms of a dollar? And the answer is no. So we're going to round it up. So here you have 30.89 rounded up would be 90 dollars per foot total. Not per foot. This is the total cost. Okay, so that's how you would do like a cost problem. It's like an extra step on top of it. It's actually, like I said, it's very applicable, especially if you own a business or you run a business. You always want to find how much your product costs, especially if you're billing on a per foot basis. So, like I said, an example. My dad, he does a lot of underground irrigation stuff, and also there's a machine that he uses to drill along underneath highways and roads. It's called a directional boring machine, or a horizontal drill is essentially what it's called. And so for him to figure out product, how much he should charge his the people who are hiring him, he needs to figure out how much it's going to cost him up front, and then he'll add, a profit margin on top of that. So that's kind of an important thing if you're a business owner, is to know like what your product costs are, to be able to understand like how much profit do I want to generate. That's always a huge thing. All right, so let's look at some area problems now, because we did some of these other ones. Some perimeter ones, but I want to do some area ones as well. So here, I might need that calculator. I'm just going to put it off to the side. It says find the area of a parallelogram whose height is, height is 7 feet and base is 17 feet. Okay, so again, I'm going to go back to the notes here, and we'll take a look quick at the area of a parallelogram. Its area is base times the height. So they gave us the base, they gave us the height. But let's write that formula down. So A is equal to B times H. So that's equal to, the base is 17 feet, and the height is 7 feet. So when we multiply that out, again, I'm going to use this because I know my limits. 17 times 7 is just going to be, it's going to take way too long, and I just want to get it done. So if anyone in here has ever had a concussion, I'll share you. This is a kind of a funny story, but when I was in college, I went snowboarding and got a concussion. Just decided not to wear a helmet and decided to go off jumps, and that was a really smart thing to do. Just kidding, it really wasn't. So I smashed the back of my head against just a lot of ice and got knocked out for probably 20 seconds. That's what somebody told me. When you get knocked out, you don't even know it until you come to. But I got a concussion from it. And the next day I went to the doctor. And when you have a concussion, you have a tendency of having short-term memory loss. Like, you can't remember things that are in your brain. It's such a weird feeling. But the doctor asked me to multiply by sevens, and I'm like, I'm getting a degree in math education. This should be a breeze, right? 7 times 1, 7. 7 times 2, 14. 7 times 3, 21. Where was I at again? So it's funny, like, it's kind of scary, actually, because you realize that, but you literally lose track of where you are in the sequence. So I literally looked at him and I was like, where was I? And he said, you were at 4. I was like, oh, 7 times 4 is this, 7 times 5 is this. And I would get lost again. And it was such a strange feeling. But be on the lookout. If that's kind of something you're experiencing, do that. If you don't get the answer, it could just be that maybe you just need to go back to your multiplication tables. But yeah, it was kind of a scary feeling. You just forget. You forget where you are in the sequence. It's really kind of weird. So, all right. So let's go ahead and take a look at another problem here. Enough of my stories. Let's do this one. The area of a circle, okay? Find the area of a circle whose radius, so r, is equal to 8.4 meters. And we know what pi is. 3.14. There's no units attached to pi, by the way. It's just a number, so it's a constant. All right, so let's go back to the notes real quick, and then take a look. So the area of a circle is pi r squared. Okay, pi r squared. You're probably asking, like, why are you going back to the notes? Don't you already know this? Yes, I do know this. I just don't want to be flying through the material, and I want to demonstrate that it's okay to look back on your notes. Like, that's not a problem. I, in fact, encourage you to do that. So area is equal to pi r squared. Okay? No, I don't have a concussion, in case you were wondering. Jeez. I know you were thinking it. Did you already forget? Oh, my gosh. No, I did not forget. I remember. I do not have a concussion. Thank you. Okay, let's take a look. So we'll substitute these values in. This is the same thing as pi times, so 3.14. Let's just go ahead and put that in. Why not? 3.14 times 8.4 squared. Okay, I'm going to show you what to do with the units here in just a minute. Again, my board is like right on that spot. You can see that. Okay, pause it if you can't and really look hard. So what I'm going to do is I'm actually going to punch it into my device. If you want, you can just do 8.4 times 8.4 to get 8.4 squared. So that's going to be 70.56. So we've got 3.14 times 70.56. And then I multiply that number in my calculator times 3.14, and I get 221.5584. Did they tell me to round? I can't be sure. They did not tell me to round. However, I'm just going to go ahead and do this anyway. So I get 221.5584 for this problem. And bear in mind, the question started with meters, okay? And I'm squaring it, so this is going to be meters squared. Meters squared is indicative of area, not perimeter or length. Perimeter is always going to be one-dimensional, which means just length. Meters, feet, furlongs. If anyone knows what a furlong is, I encourage you to look that up. And meters, I think I said that already, that is a distance. But if you do squared, that is actually area. So feet squared, square feet, square meters, meters squared, all kinds of things like that. So that was pretty much all we have, and I hope you have a fantastic day. Enjoy.